Dear students, in this presentation, I am going to explain about hash tables, which is in the fourth unit of the subject Data and File Structures. Data structures are broadly classified into two categories, linear data structures and non-linear data structures. Under linear data structures, we already learned about arrays, lists, stacks, and queues. Similarly, under nonlinear data structures, we learned about trees. Now, this presentation deals with hash tables. Hashing is an approach for storing and searching for values. In the hash table, we need to store the value on a particular location based on the key value. That is, the location is calculated from the key value itself. There is the process of finding the location based on the key value is called as address calculation or indexing or hashing. And therefore, we need one function called as hashing function or a hash function which accepts input as a key value and produce the index or the location where we need to store the key values. This is just an illustration of a hash table. Similar to any other table, that is an array, hash table contains a location from 0 to n minus 1 or table size minus 1. If, for example, your table starts size is 10, then the locations will be 0, 1, 2 and so on to 10 minus 1, that is 9. The key space, it may be anything, it may be integer or it may be a string. That is the key value which we have taken for computing the location. That key value will be given to the hash function. That hash function gives location for storing that key value. Here is an example for hash table. I have taken both array and hash table for better understanding. Key space is an integers. That means we are going to store some set of integers in array as well as in the hash table. Table size is equal to 10. That means totally we are going to store 10 elements. So in the array, the location starts from 0, 1 to 9. Similarly, in the hash table, the location starts from 0, 1, 2, etc. to 9. Here in this example, we have taken the simplest hashing function, that is mod operator. H of k is equal to k mod 10, where k is the key value. Now, we wanted to insert the values 7, 18, 41 and 94 in array as well as in the hash table. Now, let us see how we can insert these values in the array. The first value is a 7, so we will insert it in the first location, that is 0th location. Second value is 18, we can insert it in the next location, and third value 41 in the second location and 94 in the location number 3. Whereas in the hash table, we cannot insert the numbers as the order in which they arrive. We have to calculate the location based on the hash function. So our hash function is h of k is equal to k mod 10. So the first value is a 7 and 7 mod 10. We know the mod is the remainder operator. So 7 mod 10 equal to 7. The first element 7 will be stored in the 7th location. Similarly, we can calculate the location for the second element 18. 18 mod 10, the remainder is 8. So the number 18 will be stored in the location 8. For 41, the remainder is 1. The 41 will be stored in the location 1. Similarly, the number 94 mod 10, the remainder is 4. The 94 will be stored in the 4th location. Now you can see the difference between array and hash value, and you can analyze how the elements are stored in array as well as in the hash table. Here another example is given for hash table. A slight change in the table size and in the hash function compared to the previous example. You try to understand this by yourself. In the previous hash table example, we have taken a simple hashing technique. In general, a hashing technique should find one-to-one correspondence between a key value and an index or location. Here is an illustration for hashing technique or hash function. If you take any key value, you should associate with only one location in the hash table. This is another example which illustrates for finding a key for a hash function. In this example, our items contains a name and a salary. Either you can take both name and salary as a key, or you can take any one, a name or a salary as a key. In this illustration, the name alone is taken as a key and is used as an input for the hash function. This hash function, based on this key value, find location in the hash table, where in this location we can store all the elements. For example, if you take John 25,000, the key is a John. The identified location based on this hash function is 3. So in the third location, we can store both the values John and salary. There are two primary criteria or properties in deciding hash function. The hash function should be simple and fast to compute. It should avoid collisions. The keys are to be stored evenly among the cells. Now let us take one simple hash function. We can take any hash function, but it should satisfy the above criteria. Now our hashing function is, let us assume that our key contains only 2 digits and we have to add the 2 digits, and the index is the digit which is in the unit place after the addition. For example, if k, that is key, is 10, 19, 35, etc. Now we have to calculate the location or the index I based on our above hashing function. So as per the condition, our key values are of 2 digit. Now we have to add the 2 digits and we have to take the index in the unit digit. That is, in the first example, when you take 10, we have to add 1 and 0. So the sum is 1, the index is 1. Similarly, when you take the second one, 1, 9, 19, that is 1 plus 9, the sum is 10, but in the unit, the digit in the unit place is 0, so the index is 0. And similarly, we can calculate it for 35, 3 plus 5, 8, so the index is 8. And 43, 4 plus 3 equal to 7, so the 43 is stored in the location 7. You can see here the 43 is stored in the location 7. Now this is our hash table. Now accordingly, when we calculate the index in the manner given above, then 19 will be stored in the 0th place, 10 will be in 1, 49 in B will be in 3. Now you can see in the location 4, there will be 3 keys need to be stored. 59, 31 and 77, because when you add 5 plus 9 it is 14, so the unit place is 4, so the location is 4. 3 plus 1 it is 4 and the location is 4. 7 plus 7 it is 14, the unit place digit is 4, so the location is 4. So this is called as a collision, but we have to avoid this collision, and later in the presentations we are going to see some techniques for avoiding the collision. Similarly, for the location 8, it needs to store two numbers 35 and 62. There are some commonly used hashing methods are available. Some of the commonly used methods are division method, mean square method, folding method, digit analysis method. We are going to discuss one by one in the following slides. Now let us see the first method, division method. So far in the previous example, the hashing technique we used is the division method. The division method uses the modulus operator to divide a key value with the value m. Usually, the m may be a number which is equal to the table size. The choice of m is very critical in this division method. For example, if the m value, that is the table size, is divisible by 2, then the odd keys are always stored in the odd location and even keys are always stored in the even location. Let us consider the key as 11 and m as 10, where the 10 m divisible by 2. So, when you find 11 modulus 10, the remainder is 1 and 11 is odd number and the key, computed key 1 is also the odd number. That is, the 11 will be stored in the location 1. Similarly, when you take the even number, that is key 24, when we perform the modulus 10 for the number 24, the remainder is 4, the location is 4 and it is also an even number. So, when the key is even, the location is also even, which gives a biased. Therefore, the choice of m is critical in this division method. The second commonly used hashing technique is mid-square method. In this method, the key value is squared and the index is taken from the squared value. Some m digits can be taken as an index from the squared value. For example, if k is this number and m equal to 5, we have to square the k value to get middle 5 digits as an index. And this is a squared value and the middle 5 digits of this square number is 01779 and that will be taken as a key value. Some more example for mid-square method is given here. You try to understand this by yourself. The third type of hashing technique is folding method. In this method, the key value k is divided into several parts. Except the last part, all the parts will have the same length. We have to add all the parts together to obtain the hash address. There are two possibilities for given any k value after dividing into several parts. For instance, if you take any k as the sequence of digits, then there are two ways we can find the address. One is using shift folding and another one is using folding at the boundaries. We can see this in detail in the next slide. So let us take the same k, key value k as this, and our part size is the length 3. So we have to divide 3 digits into a part. So first three digits 1, 2, 3 will become part 1. 203 is P2 and 241 is P3. 112 P4. 20 is P5. No other digit, so the last part may not be equal to the length of all the previous parts. So in the first method, shift folding, we have to arrange the parts in the order and we have to add the digits. So P1 is 1, 2, 3, P2, P3, P4 and P5. We have to add the digits. So for example, when you add 3 plus 3 is 6 plus 1 7 plus 2 is 9. Similarly, when you add these digits, you will get 9. When you add these digits, you will get 6. So the address for a K using shift folding method is 699. Similarly, the second approach, folding at the boundaries, we have to take the same method but except the alternate parts are reversed. So the first part is 1, 2, 3 we will take as such. And second part it is 203 we have to take it in the reverse order. That is instead of 203 we are taking it as 302. Then third take as such. Fourth reverse it we will get 211 and fifth take as such. When you do the same digit addition we will get 897. This is the hash address for the value k using folding at the boundaries method. Here, some more example for folding method is given. Try to understand this by yourself. The last commonly used method for hashing technique is digit analysis method. The basic idea of this hashing function is to form hash addresses by extracting and shifting the extracted digits or the bits of the original key. For example, if k is equal to 6732541 and we can transform this into a hash address as 427 by extracting the digits in the even position. So now in this case 6 is an odd position, first position, 7 is an even position, that is second position. Third, 3 is in third position, odd position, 2 is a fourth position, even position. So similarly 7, 2 and 4 are the digits in the even position. So it is 724. When you reverse it, we will get 427. So this is a key or this is the address for this key K. This is a simple algorithm for hashing technique using a division method. Here, the key values are taken as some ASCII values. And this key value, we are finding the index using this modulus operator. As we discussed before, collision is a major problem in hashing technique. More than one keys may be hashed into the same address is called a collision. Here, when you take K2 and K5, when you find the address using some hashing function, if it produces the same index in the hash table, then it is a collision. We cannot store the two values, that is K2 and K5, in the same location. We have to avoid this. There are several techniques to resolve this collision. Most commonly, two techniques are used. One is closed hashing, which is also called open addressing, open hashing, which is also called chaining. In the following section, we will discuss about these two types of collision resolving techniques. The first collision resolving technique is closed hashing or open addressing. In closed hashing or open addressing, all elements are stored in the hash table itself. That is, if we try to place x in location h of x and find it occupied, then find alternate location h1 of x or h2 of x and so on. Try each in order until a location is found or a table is full. In general, there are some collision resolving strategy to generate a sequence of hash table slot, that is probe sequence, that can hold the record. Commonly used probing techniques to compute the probe sequences required for open addressing are linear probing, quadratic probing, double hashing, and rehashing. We will discuss in detail all these probing techniques in the following slides. The first type of probing technique for closed hashing or open addressing collision resolving technique is linear probing. In general, we will start computing the index or the hash address in the zeroth probe. If there exists a collision in the zeroth probe, we will go to the first probe. If still there exists a collision in the first probe, we will go to the second one. If there still exists the collision, then we will go to the next until to the ith probe. So in general, to calculate the hash address or the index for any key value k in the ith probe is k plus I mod m. Now let us see one example for linear probing. Here the m value is 7, that is the table size. We would like to insert the numbers 23, 30, 41, 49, 53, 60 and 67 in the hash table. This is our hash table. The locations are 0, 1, 2, etc. to 6. Now let us see how to insert the value 23. So our function is, hash function is 23 mod 7, the remainder is 2. Now we can insert 23 in the location 2. Next we have to insert the value 30. 30 mod 7, the remainder is again 2. We have already inserted 23 in the location 2. Now we cannot insert 30 in the same location. Here there arises a collision. Now we have to go for the next probing, that is the first probing. In the first probing, we have to add a 1 to the already computed index value. So the computed indexed value is 2. Now we have to add plus 1, 3 and 3 mod 7, the remainder is 3. Now we insert the value 30 in the location 3. Next we have to insert the value 41. So 41 mod 7, the remainder is 6. So we can insert the value 41 in the location 6. The next value to be inserted is 49. 49 mod 7, the remainder is 0. We can insert the value 49 in the 0th location. Next is 53 and 53 mod 7, the remainder is 4. We can insert the 53 in the location 4. The next value to be inserted is 60 and 60 mod 7, the remainder is 4. Already in the location 4, we go stored 53, it is a collision. Now we have to add 1 to the 4. So 5 and 5 mod 7, the remainder is 5. So in the place 5th location, we can add 60. Now the last number we have to insert, that is 67. And 67 mod 7, the remainder is 4. Already in the location 4, we have stored the number 53. Now we have to add 1 to 4, that is 5 mod 7, the location is 5 and 5 again contains the number 60. We cannot load 67 into the 5th location. And we have to add 2 to the 4, so 4 plus 2 6 and 6 mod 7, the remainder is 6. So we have to insert the 67 in the location 6, but we cannot because the location 6 already contains the value 41. Now we have to add 3 to the third prob, 3 to the 4. So 4 plus 3 it is 7 and 7 mod 7 it is 0. The remainder is 0. We have to try to insert the 67 in the location 0. Now again the location 0 contains the number, the key value 49. Again there is a collision. We cannot insert it. So we have to go to the next prob. Now it is fourth prob. So 4 plus 4 it is 8. And 8 mod 7 the remainder is 1. Now the location 1 is free and we can insert the number 67 in the location 1. In this way we can insert a value in the case of collusion using the approach linear probing. The major drawbacks of linear probing is the primary clustering. That is, some key values are clustered in larger groups, so the sequential search becomes slower. This is a major drawback in this type of probing technique. The second type of probing technique for closed hashing or open addressing is quadratic probing. The small difference between the linear probing and the quadratic probing is, in the linear probing, we will add I to h of k, whereas in the quadratic probing, we will add I squared instead of I. So, after computing the zeroth prob, in the first prob computation, we will add h of k plus 1 squared, that is 1. For the second prob, we have to add h of k plus 2 squared, that is 4. Similarly, for the third prob, we will add h of k with the 3 squared, that is 9. Similarly, in general, for ith prob, the h of k is added to I squared to calculate the index for the key value in the hash table. Here, this quadratic probing is less likely to encounter the primary clustering problem. Now, let us consider one example for quadratic probing. Here, the m value is 10, that is the table size is 10. So, the hash table contains the index from 0, 1 to 9. Here, we wanted to insert the number 18, 89, 21, 58 and 68. First, we'll try to insert 18, 89 and 21. So, our m value is 10, 18 mod 10, the remainder is 8. So, the 18 will be stored in the location 8. Similarly, 89 mod 10, the remainder is 9. The 89 will be stored in the location 9. When we take 21, 21 mod 10, the remainder is 1 and the value 21 will be stored in the location 1. Now let us consider inserting the key value 58 in the hash table. When we compute the index value for 58 in the zeroth prob, it gives the value 8. But we have already stored the key value 18 in the location 8. So we have to go for the next prob, that is 1th prob. So as per the equation, it is h of k plus I squared. So h of k is 8. 8 plus 1 squared is 1. When we find the remainder by 10, it gives 9. And again, the ninth position contains the key value 89. It is a collision. So we cannot store it in this location 9. We have to compute the next index. So we are going to the next prob, I equal to 2. So 2 squared is 4. H of k, it is 8 plus 4 is a 12. 12 mod 10. The remainder is 2. Now we can store the value 58 in the location 2. Now we consider inserting 68. So in the 0th prob, it gives the index value 8 and the location 8 already contains the number 18. We cannot insert it, it is a collision. We will go to the first prob, it gives the index value 9. Again, in the 9th locations, we have already stored 8, 9, it is a collision, we cannot insert it, we have to go to the next prob. We will take I equal to 2, that is a second prob, it gives the address 2 and in the location 2, we already stored the key value 58, we cannot insert it here. So we will go to the third one, I equal to 3, the third prob, it gives the index value 7. In this location 7, we can insert the key value 68. So in this way, we are inserting the values using the quadratic probing technique to avoid collision. The quadratic probing also has one drawback. Though it does not suffer from primary clustering, that is, keys hashing to the same area like linear probing, here the keys hash to the same spot, which is called as secondary clustering. To avoid this, another probing technique called double hashing is introduced, which is presented in the next slide. The third type of probing technique for closed hashing and open addressing is double hashing. Double hashing uses a two hashing function, that is h hash function and g is a second hash function. The general form is h dash of k comma I equal to h of k plus I into g of k mod m, where m is the table size. As usual, we will compute the address in the 0th prob using the h function alone. If there exists a collision, then we will go for the first prob using the two function hashing function h and g. So in the first prob, the index value will be calculated by h of k plus 1 into g of k mod table size. Still there exists a collision. We'll go to the second prob. Now it becomes h of k plus 2 into g of k. Whereas when we are in the third prob, then it will be h of k plus 3 into g of k. And similarly, when we are at the ith prob, we will calculate the index using h of k plus I into g of k mod table size. Let us consider one example for double hashing. There are two hashing functions h and g. H of k is k mod 7 and g of k is 5 minus k mod 5. Here our table size is 7, so m value is 7. And we would like to insert the values, that is key values 76, 93, 40, 47, 10 and 55. And this is our hash table. The location starts with 0, 1 to 6 since our table size is 7. First we have to insert 76. So when you perform 76 mod 7, the remainder is 6. So the key value 76 is inserted in the location 6. Now let us take the second value 93 and when you compute the location it gives 2. So we can insert the 93 in the second location. Similarly, when you take the 40, when you compute the location, it gives the value 5. So the index 5, we can insert the value 40. Now we have to insert the 47 into the hash table, or we have to find the location for the key value 47. When you find the remainder, that is 47 mod 7, it gives the value 5. In the position 5 already has a key value 40. The position 5 already has a key value 40. we cannot insert 47 into this place. So we have to go to the first probe. Only in this first probe we have to apply the second hash function. So now our address calculation hashing function will become h of k plus I. Here I value is 1 into g of k mod m, where m is a table size. Here in this example it is 7. So we can assign 7 here in the place of m. So h of k, as we know, it is 5. So 5 plus. Now we are in the first probe. So 1 into, what is g of k? It is 5 minus k mod 5. So 5 minus k. The present key value is 47. So 47 mod 5. And 47 mod 5 is 2. So this becomes 2 minus 5 minus 2. So it is 3. Now 5 plus 1 into 3. So 5 plus 3, it is 8 mod 7, it gives 1. The remainder. So in the place location 1, we will insert the value 47. Now you can find yourself to calculate the locations for the remaining values 10 and 55. The next type of collision resolving technique for closed hashing and open addressing is rehashing. When the table gets too full, we have to create a bigger table, usually 2x as large. Then we have to hash all the items from the original table into the new table. Usually, when the half of the table is full, that is the table, the load size, lambda is equal to 0.5, then we can rehash it. When an insertion fails, we can rehash it. Here we have to consider the cost of rehashing. It is really a challenging one. The second type of collision resolving technique is open hashing or separate chaining. Here, the hash table uses the linked list structure. All the elements that hash to a particular bucket or a location are placed on that bucket's linked list. So, the hash table stores only the addresses of the connected linked list in this approach. Here is an example for open hashing or separate chaining. Given the hash function and the corresponding computed index value for the given input is also given. This is the input and this is the computed index value. Now we can see for the value 18 and for the value 10, it gives the same index value too. So this is our hash table. It gives index to the corresponding linked data structure or linked list. So in the case of a element 18, first it creates a one list for the index 2. If the same index exists the second time, that key value will be inserted at the beginning of that previously created list and it will be directly pointed from the corresponding position of hash table. In this way, this open hashing or separate chaining works. There are some advantages in open hashing or separate chaining. Here, an overflow situation never arises since it maintains a list. It can contain any number of key values. Collision resolution can be achieved very efficiently when compared to closed hashing or open addressing scheme. This table summarizes the expected number of probes for searching with the load factor lambda equal to n by m. for unsuccessful search and successful search. This graph depicts the expected number of props for the given load factor for the various probing technique, that is linear probing, double hashing, and chaining. Here, the successful and unsuccessful are also denoted. Unsuccessful with a thicker line and successful is depicted by thin line. This table gives you the recommended load factor for the various collision resolving techniques. Separate chaining, the recommended load factor is less than or equal to 1. Linear probing or quadratic probing, the recommended load factor is half full, that is lambda is less than or equal to 0.5. Similarly, for double hashing, it is half full. With this, I can conclude the presentation on hash tables. For more details, you please refer the textbook and the reference books given in your syllabus. Thank you.